Hey, welcome back, class. On this tutorial, we are going to find the mean, the standard deviations, and the expected numbers of variables for a discrete variable. This is going to be helpful with homework 5. Specifically, I think is questions 2 and 3. So if you're struggling with those two questions, you may want to stick around. All right, so here I do have a problem similar to the one that you have on your homework. And I know this is a little bit different than uh, what the book kind of goes over it. So I wanted to explain a couple of things on this. So here the question says the number of arrivals per minute at a bank located in the central business district of a large city was recovered over a period of 200 minutes. With the results shown in the table below, complete A through C to the right. So here is the numbers of arrival, here is the frequency. Basically what this is saying is there were 12 minutes during those 200-minute periods when no one showed up. There were 22 minutes during those 200 minutes periods when 5 people were showing up at the same time. So we are compute the expected numbers of arrivals per minute. Basically they're asking us what is the mean of this discrete variable. And then once we have that, they're asking us to compute the standard deviation. And finally, it's asking us what is the probability that there will be fewer than 2 arrivals per minute. So one thing that I done to make it a little bit easier on you guys, I do have the formulas here, which you can find on your book. Now, look at this, expected value, right? That is mu, which is the mean of a discrete variable. So this, what it's asking here is the expected numbers of arrivals. So basically, it's asking us what is the mean. That's all this really asking us. Okay, so let's start working on this. I am going to open a brand new book from Excel. And again, we're going to use Excel because it's so much easier to manipulate data. Here is a new book. Let me just type the data that we're getting from the problem here. And we have, okay, so we have arrivals. And then we have our frequency. Now on the book, it's giving us the probability, which is a little bit different than the frequency, and we'll talk about that in just a minute. So we have 0, 1, and we have 8 observations, so we're going to go all the way to number A here. Okay, and our frequency here is 12, 19, 49, not 419, but 49, 45, 31, 22, 11, 7, and 4. Okay, so first thing that I like to do now that I do have my data there, I want to make sure that I'm not missing any numbers, that I mistype any number or anything like that. So I'm going to write my total in here. And according to the problem, right, this was 200 minutes. So all these numbers should add up to 200 minutes. So I'm going to add them all up. And I do have 200 minutes. That tells me that maybe I type those numbers, but if I added one extra number, I subtracted it somewhere else. That wouldn't that make it correct, but it's kind of like a check to make sure it is correct. Now, on the book, a lot of the things that we see is giving us the probability. Here is giving us a frequency. So frequency and probability are two different things. But with the information we have, we can get the probability. So what is the probability that 0 people is going to show up? And to do that, we're going to type equals, and we're going to divide our frequency by our total numbers of minutes that we observe. So, okay, and the probability of 0 people arriving is going to equal 0.06 or 6%. Now, if I just grab the little corner right there, all of my values should add up, and I have them here. Now, remember, one of the things that we learn, right, is the probabilities is going to be from -1, meaning that will never happen, to 1, that means is absolutely sure that something will happen. Basically, once you add these probabilities here, it should add up to 1 because all of those values should be inside of 1. So what I'm going to do is I am going to add all of my probabilities, and all of my probabilities should equal 1. ensuring us those. Okay, so now that I have that, we can follow what the book is telling us, or we can look at the formula here. And here's our formula. So mu is the expected value of x, and here is the formula where basically we need to add all of the values, all of the probabilities of those expected values. Right here is the probability of the discrete variable x, the and the numbers of values for the discrete variable of x. So what we're going to have to do here is really simple. We are going to multiply the numbers of variables by our probability. So that is the part of the formula. So let me just write that in here so we know what we're dealing with. Okay, so we have x of I, and then times the probability. X is going to equals x. All right, so basically what we're saying here is we need to multiply our number of variables by our probability. So 0 times 0.6, and that will be 0, of course. And then now that I've done that, all I have to do is drop all of those down here. And looking at our formula, we need to add all of those numbers, and that will give us our mu, or our mean. So here we are. So our mean is going to equal this value here. All right. So again, to get your mean, all you do is multiply your numbers of variables by the probability of that happening, and then you add all of those values, and that will be your mean. Okay, so next step we're going to do is we need to find the variance. To find the variance, let me put the formula here. Here is the variance of a discrete variable. To find the variance, right, we have to add. So once again, we're going to have to add the values of xi, which is the number of value that we're looking at it, minus, remember this, if this seems familiar, is because it is this part right here. That's your mean. So the number of value minus the mean, and then we elevate that to the second power. So we're going to write this down here so we know what part of the formula we are dealing with. Okay, so let me just write that down in here. And here we have, where was my formula? Oh, here it is, right? So we have, open parentheses, the expected value of x minus expected value of x. And then we are going to elevate that to the second power. All right, so simple enough. We're, okay, so what we need to do is subtract the arrivals minus our mean, and then we elevate to the second power. So here is our arrivals. Arrivals minus, oh, sorry. This is going to equals arrivals minus our mean. Then close parentheses, and we elevate that to the second power. Okay. So once again, looking at the formula, right, we have our number of arrivals. In this case, is 0, minus our mean, which is 3.165, and then we elevate that to the second power. Basically, we're saying 3.165 elevated to the second power is 10.01. I am going to put, once again, put the dollar signs in here so we know that the data is fixed. Okay, and then all I need to do is grab this little corner, drop it all the way down, and that will give me all of my values. Okay. So now that I've done that, let's go back to our formula here, and now we can do the second part of this, right? Then we need to multiply P when x equals xi. So here it is. We have, let's take a look at this. Basically, we need to find that P x is going to equals xi, and we close the parentheses. All right, so basically all we have to do is multiply the value that we find by our probability. So the value that we find was 10.01, and we need to multiply by the probability. So 10.1 times our probability, and that gives us that value right there. And once again, all we gotta do is drop this down. Okay, so now that we have that, if we look at the formula, right, it says that we need to add up all of those values. So once again, I'm just going to type equal sum, and then I am going to include all of this, and that will find my variance. So here is my variance. It's going to equal my variance. Oops. My variance is going to equals 3.28775. Okay. Now that we find our variance, okay. So we did all of this. We find our variance. Now we need to find our standard deviations, right? Before we do any forward, let's just answer this question. Okay, so we already the expected numbers of arrival per minute. On this case, our expected numbers of arrival per minute, it is going to equals our mean. Remember the formula? So our mean was 3.165, right? It's asking us 3 decimal places. So that'll be 3.165. 3.165, 3 decimal places. All right. Yep, that sounds right. Now we need to find out a standard deviation. So here is our formula for our standard deviation. So we can do all of that, but because we already find our variance, all we have to do is take the square root of the variance, and all we have to do is take the square root of the variance, and that is our standard deviation. So we're gonna type in here, standard deviation is going to equal the square root of 3.28775, and that will be our standard deviation, 1.8132. Okay, so our standard deviation will be 1.813. All right, 3 decimal places. All right, so now what we're gonna do is, what is the probability that there will be fewer than 2 arrivals per minute? So the probability of basically probability of being less than 2. Okay, so what we need to do in order to do that is really simple. All we have to do is add the probability of 0 arrivals minus plus the probability of 1 arrival. If we add those two, that will give us the probability of having 1 or 0, which is less than 2. Or you can do the probability of 1, and then you can subtract all of this, and that will give you the same number. So we're going to take the easy route, and we're going to say the probability of having less than 2 people arriving is going to equal the probability of 0 people plus the probability of 1 people arriving, and on this case is 0.155. So let me get back to my assignment here, and 0.155. Okay, and that will answer this problem. Take a look at it, go over it. If you have any questions, send me an email, reach out to me, but that's how you will solve this problem. All right, everyone, have a good day.